Hello everyone and welcome back to my YouTube channel. If you're seeing me for the very first time, my name is Pauline the Analyst. So in our previous video, we covered how to use the alter table using the not null, unique and primary key constraints. Today we are going a step further. We will explore how to use the foreign key constraints, the check constraints and the default values, since these are the essential tools used to maintain data integrity in your databases. So whether you are a beginner or an advanced user, this tutorial will help you master these concepts. So let's dive in. So this is what we'll cover in this video. 1. Foreign key constraints. This is how to link tables and enforce relationships. 2. Check constraints. This is how to restrict column values. 3. Default values. How to set automatic default values for columns. 4. A hands-on example where we'll modify our pizza delivery app database with these constraints. And finally, best practices to avoid common mistakes when altering tables. So let's get started. So our first segment will be using the foreign key constraints. So let me explain what a foreign key is. A foreign key creates a relationship between two tables, ensuring that a column in one table matches a primary key in another. So this prevents orphaned records and keeps your data consistent. So as you can see from my screen, we want to create two tables. Let's create two tables called pizzas okay, and then in this table I need it to have a pizza ID with pizza underscore ID as the primary key. Okay, guys. Then next, we'll also create a table called the orders table. And this needs to reference pizza ID. Okay? Nice. So let's first create the orders table. Okay, guys? So for those who don't know, to create a table, you just first start by writing create table. Then your table name, in my case, is the orders table. Okay, then open your bracket to insert your column name. Okay, so for my first column, I want it to have the order underscore ID. Okay, and since this is a number, its data type will be an integer, which is represented by int, and this will be the primary key. Okay, comma. Then next, we will have the customer name as my next column, and since it's text, its data type will be the varchar, and I don't want it to have more than 100 characters in it. Then for my next column will be the pizza ID column, and since it's a number, its data type will be an integer. Okay, and then for my final column, I want to have the order date. From its name, its data type will be a date. Okay, then close your brackets, then finish your query. Okay, then highlight it. Let's highlight it and then execute it, and voila, our command has been completed successfully. So when we go back to our table, let's go back, select from the orders table. Nice, here it is. So highlight it and execute it, and voila, as you can see from my screen, my table has been created. The order ID, customer name, pizza ID, and order date. Then next, I want us to add a foreign key constraint, okay? Let's add a foreign key constraint. Nice. So for us to do this, we'll have to alter the table that we have just created, okay? So we'll write alter table, that is orders, okay? Then we want to add a constraint in it. So add constraint, that is the foreign key represented by FK underscore pizza order. Pizza order. Then next we'll have the foreign key. Foreign key for the pizza ID. Then it should have its references. So references is the pizzas table that we just created. Pizza ID column. Then close our bracket. So let me lower this so that you can see my query very well. So let's highlight it and execute it. And now, this is exactly what I want. The foreign key, FK pizza order, references invalid table pizzas, and then you can see could not create constraint or index. See previous errors. So now SQL Server will block any order that references a non-existent pizza. Very, very simple. So now our next segment will be moving to check constraints. So let's check constraints. Nice. So let me explain what a check constraints is. So a check constraints lets you enforce rules on column values. So for example, it ensures that your prices are positive or dates are in the future. So if you want to add a check constraints to the pizzas table that we created, let's write that down. Add a check constraint to pizzas table. Okay, so what we'll do here is to alter the table pizzas. Okay, so alter table, then the table name is pizzas. Then add constraint. That is CHK, meaning check underscore price positive. Price positive. Okay, next is now check, which is price that is greater than 0. Okay, so if you try to insert a negative price, it will definitely show you an error. Okay, so this prevents anyone from setting a negative price because free pizza is great, but not for business. Okay, guys? So on our next segment, we'll move on to the default values. Okay, so let me explain what a default value is. So a default value automatically fills in a column if no value is provided, okay? And this is usually useful for timestamps, statuses, or default settings. So today we want to let's add a default to the orders table. So add a default to the orders table, okay? That is what I am about to do. So to do that, we will have to come and alter the table. So alter table, orders, then add a constraint. We are adding constraints. So add constraint, df meaning default. So df underscore order date. Which is default get date for order date. Nicely done. So if you insert an order without a date to show autofill, okay? So let's do this. Let's alter the table and see. Exactly. Now, if someone forgets to set an order date, SQL Server uses today's date automatically. Okay, for me, it's the 9th of April of 2025. So next segment, let's have a hands-on example putting it all together, okay? So we're moving on to the hands-on example. Hands-on example to put it all together. So to enhance our pizza database, first we'll start with 1, a foreign key linking orders to pizzas, 2, a check ensuring quantity in orders is at least 1, and 3, a default setting order statuses to pending. So add quantity column to orders table. That will be alter table orders. Okay? Then next, we want to add a quantity. So it will be add quantity. That since a quantity will be a number, the data type will be integer, int. So highlight it and execute it, and voila, we have added a quantity to the orders table. Next, we want to ensure that the quantity is at least 1. Ensure that the quantity is at least 1. So what we'll do, we'll write alter table, the orders table, then add a constraint, that is the check constraint, chk underscore the quantity minimum. Quantity minimum. Then check into bracket the quantity is greater than or equal to 1. So close your bracket, highlight it, and then highlight it, and then execute it, and voila. Then next, we want to add status with default. Add status with default. Okay, so how do we do that? Using the alter table. So alter table, the orders table that we created, then add order status, order underscore status. Our data type will be a varchar, and it should not have more than 20 characters in it since it's a text. Then our constraint, we are adding the default constraint, which is df, okay, underscore status, since we are adding a status. So default status, okay, then default will be pending. Okay, so highlight it and execute it, and voila, our command has been completed successfully. So in our next segment, I just want to tell you the best practices and common pitfalls as an analyst. So before you go, remember, these are the best practices. So 1, you have to name your constraints. This will help with debugging. 2, test constraints with invalid data before deploying. 3, avoid excessive check constraints. This can slow your performance. And finally, document changes so your team knows what has been modified. Very, very simple. That's how you use foreign key, check, and default constraints in SQL. If you found this video helpful, smash the like button and subscribe for more database tutorials. If you have any questions or suggestions for the video, drop them in the comment sections below because I am here to help. So until next time, happy coding!